For 2627, rational functions and asymptotes. So these are all going to have fractions in them, and the graphs are easy, but I'm not going to lie, a little time consuming to draw. So let's get into it. First off, determine the values of x that make each of the following undefined. So we're kind of back to that domain talk, way back from like chapter 1. So easy question for you. What is the only number you could not use for x in letter A? -5, because that would make the denominator 0, 0 under the line undefined. Now, -5 then, if I had to graph it, which we're going to graph it in a minute, would be my vertical asymptote. It's going to be a line I'm going to get very close to. I'm not going to cross or touch. All right, what's your one value in B you can't use?
7.
7, got it. 7 minus 7, 0, undefined. Now, quadratic here in C. So there's going to be two answers. And remember, I said at the beginning of the year, I keep saying it, when you least expect it, factoring just pops right on up and slaps you in the face. We can factor this trinomial. What multiplies to 12 and adds to 7? 4 and 3. So what are your two values you cannot use in letter C? Got it. So if I had to graph this, which we're going to graph them, that just means you have two vertical lines we're going to draw in first, and we won't cross or touch. So that is the next thing we have to talk about is vertical asymptotes, horizontal asymptotes, other things. So we're back to a lot of graphing today, which again, not difficult. Can you do a lot of it on your calculator? Sure. But of course, there's a lot of things to answer. We're going to be doing domain. We're going to do range. We're going to talk x-intercepts again, y-intercepts, vertical asymptotes, horizontal asymptotes. Whew, a lot of vocab there. And I'm going to save the slant probably for tomorrow. We'll just see where it leads us. So rational function, super easy, of course. A function written in the form, as you can see, it's going to be a fraction. And we just talked about it. Your denominator can equal 0. Okay, we know that. So vertical asymptote, align the graph approaches from the left or right. Of course, we're not going to actually touch it. To find it, it's that value that makes the bottom 0. So we're just going to, by setting the denominator equal to 0. And just like in those warm-up problems, most of you can just mentally do that and not have any work. You know, I'm probably going to be dramatic and draw some work. So, of course, if I'm having to graph this, -5 is my vertical asymptote. 7, vertical asymptote. -4, -3, vertical asymptotes, plural. Now, we're also going to have horizontal asymptotes. As you can see from this slide, it's a little bit more involved. Not hard, but just a little bit more involved. So, line the graph approaches, of course. Notice it says analyzing the degree. You're looking at those exponents of the numerator versus the denominator. So, you have actually three possibilities here. The degree of the top is smaller. So you have maybe x squared over x cubed. The top one's smaller. That's my favorite one because you don't have to do any work. It is automatically the horizontal line, y equals 0. Done. That's it. Okay, all right, I like that. Now, you could have where the degrees are the same. So maybe you have an x cubed over an x cubed. Now, it's still easy, but not quite as easy as situation A. We got to do a little bit of work. It's the ratio, no, it's a fancy word for fraction, of the lead coefficients. So it's the lead coefficient of the top over the lead coefficient of the bottom. So we have to know all of this vocabulary. Degree are the highest exponents, lead coefficient, the value in front of it. Now, we could have this third possibility. The degree of the numerator is larger. So we've got smaller, equal, larger. Those obviously are the three situations. If the degree of the top is larger, there is no horizontal asymptote. It kicks it into a slant. And that I'll probably save for tomorrow. We'll just see what we have for time today. We're going to focus on our vertical and horizontal asymptotes. Okay, last thing we're going to talk about before we start drawing. You could have a hole in the graph, or what we call a point discontinuity. Now, we have to know when this happens. This happens when you have a common factor. Oh, back to factoring. We can never leave factoring. And of course, to find that, we just set that common factor to 0. Now, if you're like, what does she mean by common factor? So let's say you factor the top into this, and you factor the bottom into this. What is the common factor? X minus 1, okay? So what I would do to find the whole is I would set that to 0. So wherever x is 1 is where I'm going to mark a little hole in the graph. So that's just to be clear on what we mean by common factor. Okay, all right, let's start easy. Let's start easy with some kind of basic ones and work our way up. So I look at this, I'm like, well, this doesn't look any too craziness, okay? Again, you can use your calculator to help sketch them. I'm going to do some of it by hand, of course. So first things first. For the following, identify any horizontal vertical asymptotes, point discontinuity, and graph it. So 1, there is no hole in this graph. There's nothing to factor out of the top. There's nothing to factor out of the bottom. I don't have a hole. I'm not going to worry about it. Now, I kind of go out of order of the directions. That's just how I work. I like to find the vertical asymptotes first because I think they're the easiest. Let's start easy, right? So vertical asymptotes happen when the denominator is 0. Now, some of you can just mentally do it, solve it. I don't care. I'm going to be fancy right now. So, of course, if we solve that for x, we get 0. Plus or minus 0, which is all just 0. So the very first thing I'm going to do is draw myself a vertical line at 0, which I know is right on your y-axis. It's hard to see in pencil. Do the best you can. Next thing I'm going to put on is the horizontal asymptote. Now this is where you compare the degree of the top to the degree of the bottom. So I'm looking at the top, and I was like, there's not even an x on the top, okay? But there really is, we got to be smart here. 1 would be the same as x to the 0. Because isn't anything to the 0 power 1? So I'm recognizing I have 0 is the top degree, 2 is the bottom. That's my favorite case. Whenever the top degree is smaller, 0, it's automatically the line y equals 0. I don't have to do any work. Winning. Okay, so I'm going to put a dashed horizontal line there. And now you could go to your calculator, and I see some of you already punching it in. I don't care, whatever. I'm just going to make an old school T-chart here. And I don't think I need a ton of points. Now, here's how I do it if I'm going to do it by hand. If our vertical asymptote's at 0, I just put numbers on either side of 0 in. So I'm going to put -1 in and 1, and I'm going to do a little mental math here. If I put -1 in for x and squared, I'm going to have 1. So 1 over 1. I'm going to plot it. Now, super easy to draw that part of the curve. I'm going to draw close to the vertical and then close to the horizontal. Okay, let's do 1. If I put 1 in, 1 squared 1, 1 over 1. I'm going to plot that point. Same spiel, close to the vertical, close to the horizontal. Now, I know it doesn't ask for anything more on this problem, but clearly because I know it's on your quiz Friday because I made it, it's going to ask you like for x-intercepts, I'm going to throw it on here, y-intercepts, it's going to ask for domain and range. I know technically it doesn't ask for all that on this problem, but you know, I love to review. I can't help myself. So don't stress it. You know what x-intercepts are. Look at the graph. Where does it hit the x-axis? Nowhere. Because remember that x-axis was our asymptote. We're not going to touch it or cross it. Where does it hit the y-axis? Nowhere. We're not going to cross or touch that red line. Okay. Now let's talk about domain. We've talked about domains a lot in this class. I can look at the graph. Remember, domain is your x coordinates, and ask myself how far left and right are we going to cover. I could also look in the original function and ask myself if there are any numbers that don't work. So if I look at the graph, I'm like, well, this is going to go all the way to the left. This is going to go all the way to the right, but we do have a little glitch. The one number you can't use for x was 0. That makes the denominator 0, undefined under the line. 0 under the line is undefined. So I'm going to say, oh, numbers. X can equal 0. So basically, whatever your asymptote is, that also corresponds or translates kind of a 2 for the price of 1, the one value you cannot use in your domain. It's going to be kind of, let's look at the range here. So again, range wise, lowest to highest. So lowest, highest. So our graph is all above the green line, 0. So I'm going to say all real numbers, y is greater than 0. And I don't care, I know I'm way at the bottom here. I don't care either if you do interval notation for those. It's up to you, okay? I just threw it on there, however you want to do it. So I know it didn't ask for those purple things, but I know on your quiz it's going to ask for all of that stuff, so I'm just going to do all the stuff here for the love of math. Well, that wasn't too bad. Okay. So I'm going to do the same thing. Vertical, horizontal, I'm going to get it drawn. We'll answer all this stuff. So vertical. Now, I know a lot of you can just look at it and do it in your head, that's fine. We're going to set the denominator to 0. All right, well, I'm just going to add x over, so we're going to have 2. I like it x equals, that's what someone like it, so I'm just going to switch it. I know that's a whole lot of work for something super easy. Just x equals 2, let's draw it. Got it. All right, horizontal asymptote. Now here's where we have to compare the degrees. So the highest exponent on x. So you have x to the first, x to the first. So let's click it back here. When they are the same, it's the lead coefficients. But be careful on this one. It's not really in the correct order. Those variables, the x's should be first, and then it should be the numbers. So when I'm looking at the lead coefficient, like I said, the order is really jangoed. It should be the variable first. Now, do you have to rewrite it? No. You can just look at it and realize, okay, the coefficient on the top x is a 1. Coefficient on the denominator, -1. And of course, I'm going to simplify. Probably did that with a lot less work than I did. Okay, let's draw our horizontal line. Now, you're welcome to punch it in the calculator to get the T-chart to graph some points. Now, if you were typing in the calculator, and I will do one in the calculator for you, I would, of course, use the horizontal fraction bar to put it in. You know, I'm old school. I'm going to make it by hand here. So here's how I make it by hand, and here's how even when I look in the T-chart to get my points. So if my asymptote's at 2, I just go on either side. So I'm going to back up to 1. I'm going to bump up ahead to 3. So those are kind of the ones I would be looking for in my T-chart in the calculator. I'm going to put them in, go old school here. 2 plus 1, 2 minus 1. So I've got the point 1 comma 3. Okay, so close to the... Let's do the horizontal, or the next one, the 3. So again, 2 plus 3, 2 minus 3. So you really have the ordered pair 3 comma -5, which again, you can get off your calculator. Put my arrow on there. Not the best graph I've ever drawn, but it works. We got it. Okay. Now, I know it's going to ask for all of this on the quiz. I'm going to, of course, let's do domain and range over here so I don't get too scrambled. Now, x-intercept. You can probably get that off of your graph on your calculator. Remember, the x-intercept, which don't trust my drawing here, okay, we know my drawing skills, x-intercept, where it hits the x-axis. So I'm looking for where y is 0. So again, I would just get this straight off the calculator. You're going to see that it hits the x-axis at -2. Clearly, I can't draw that great, okay? So get that off your calculator. You're going to see also it's going to hit, again, I can't draw that great. You're going to see it hits the y-axis, or I guess put 0 in for x. If you put 0 in for the x's, you're going to have 2 over 2 left. You can get all that straight off the calculator. Don't do any more work than you have to, right? Because it's already a pain to mark all this stuff out. All right, let's do domain for real numbers. So again, bless you. I'm looking left to right, x-axis. This blue piece here is going to cover all the way to the left. This one's going to go all the way off to the right, but you're going to have a gap here. What's the one number we couldn't use for x? 2. That was our vertical asymptote. What's the one number we got to look at we can't use for y? So if I'm looking lowest to highest, this is going to go all the way down, this piece. This one's going to keep going all the way up, but we're going to have a gap right there at my green horizontal asymptote. We can't equal -1. So whatever your asymptotes, your boundary lines, those are not points on the graph. That's going to be in your domain and range. All right, let's do C. Whew. Now, I don't love C. I don't love it. Because I'm looking at it, and all those terms have an X on them. So I think we could simplify a little bit, and we're going to have a common factor. Get ready for it. Now, as always simplify before you do anything. I couldn't simplify the other ones, meaning factor. I can pull an X out of this guy on the top and an X out of the bottom. Now, of course, those X's cancel each other off. I'm just not going to mark them off so I don't make a mess here. So I'm down to this. So this is the function I'm going to work on graphing. Now, I'm going to use yellow even though I know it doesn't show up the best. Because you have this common factor, I'm just in the back of my mind, I know there's going to be a hole in the graph. And I'm going to get to that when we get to the drawing. But I'm just kind of tabling that right now. All right, vertical asymptote. Now here's the other thing. If you've looked on your calculators for the graphs, of course, it's not going to show you the asymptotes. It won't draw those horizontal and vertical lines on. It will just be giving you the blue curves, okay? So just be aware of that. All right, let's do it here. So of course, vertical asymptote, I set the bottom to 0. Some of you can just mentally look at that and solve it. X equals, what's X? Why did we make it a fraction? Oh, okay, here we know how great my artistic skills are. Here we go. So I'm going to ballpark a half. I'm going to try to draw it straight. I can't give you any promises on this. This is why in college I took music classes instead of art classes. Okay. All right, let's do the horizontal. Now, horizontal is where you compare those exponents, the degrees. We have x to the first, x to the first. So when they are the same, it is the lead coefficients over each other. So the lead coefficient in the numerator is 1. Lead coefficient in the denominator, 2. Man, another fraction. Who made this problem? Okay. Yeah. All right, okay. Let's make a T-chart here. Okay. Now, of course, you're welcome to get some points. Don't think you have to do fractions just because we have fractions on the asymptotes. You're welcome to get some fractions off, some points off of your calculator. But here's the one thing I'm going to table on this. That's why I haven't started the table yet. So at first I'm like, okay, we're at a half. I'm going to put in 0 and 1. I was like, am I? No, I'm not. I'm not going to at 0. Because here's the thing. You have this common factor. We have a hole in the graph. That is going to occur when you set your common factor to 0. So we're going to have a hole at 0. And I am going to get the y coordinate to it in a minute. But for right now, I'm not going to put 0 in here because there's going to be a hole. I'm going to put -1 in. And then let's go to the right of it. Let's put 1 in. Okay. Now I'm going to mental math it. You can look at it, you can calculate, whatever. So I'm going to have -1 plus 2 on top. 2 times -1, -2, minus 1. So I have -1, -1/3. All these fractions, just ballpark it. Okay, that looks good enough. Now I'm just going to plot that point for right now. I'm not going to draw the curve quite yet because I'm worried about the hole. I'm going to get to it. Let's put 1 in. 1 plus 2. 2 times 1 is 2. 2 minus 1. So I'm going to plot the point 1, 3. Okay. Okay. Now before I draw the curves, the only reason I paused on drawing the curves, it's, close to the vertical, close to the horizontal, is because of this. I need to know where the hole is before I draw it. So just like we know it's at 0, just like I did the T-chart, I'm going to put 0 in here for x and calculate it. 0 plus 2, 2 times 0, 0, 0 minus 1. So I'm going to have a hole at 0, -2. Okay, so I'm going to mark that on the graph. I'm going to draw a little open circle there. I know that's very large. Okay, it's hard to draw on this board. But I'm going to put my open circle there. Now you can draw your curves. So I'm going to draw close to the horizontal. I'm going to get close to the vertical, but I'm watching out for my yellow point discontinuity. Very fancy, I know. Same thing, we're okay over here, horizontal. vertical. Got it. Got it. Hey, let's do domain and range. I know it doesn't ask, but I know it's going to work. All right. Somebody's going to start them on. Okay. So here we go, domain and range. These are a little trickier because we have two values for each you can't use. Now, for x, we're never going to touch a half. A half was our vertical asymptote. So I'm going to say x can equal a half. You also have the whole. So x also can equal 0. Okay, range. So my horizontal asymptote was also at a half. Who made all these fractions? This is awful, right? A half, so I can't use that value. So I can. What is the second value you'll never answer for y? -2, the y coordinate of where your point discontinuity is. Yeah. That one's a tricky one for domain and range. Any questions on that? Okay, let's fill out the next thing. Like I said, I think I can get through example 2 and we'll save the slant for tomorrow. So just to kind of give you some guidance here, you know, how to do this. So first off, I always try to simplify. Now, that is like the last problem. What does that really mean? I'm going to try to factor and I'm going to try to cancel, of course. Because if you can factor and cancel, you have that point discontinuity. So I'm looking for that right away. All right, find and plot. Let's do y-intercepts. Now, of course, okay. Do I always find them algebraically? No, sometimes a lot of times you're lucky and you can get it right off your calculator, right off the graph. So fancy notation, f is 0. That really means you're putting 0 in for x. You know that. All right, x-intercept. Now again, I can't say I always go through and find it algebraically like it's telling you. I would say 99% of the time you can get it right off the graph on your calculator, okay? But of course, just here's how you would do it. You would set the top equal to 0. Or of course, x-intercept, you're looking for where y is 0. Always write those as ordered pairs. You know that. Okay, I usually, you know, like I said, kind of do this stuff a little out of order. I like to do the vertical asymptote first. I'm going to abbreviate. I don't have very big blanks here. By finding the zeros of the denominator, you set that denominator to 0. So I always kind of start there. Then I do the horizontal. By examining the degree, that's the highest exponents of the top versus the bottom. All right, from there, I'm just, you know, it's T-chart. I'm just getting some points and plotting them, blah, blah, blah. So plot at least 1 point beyond and 1 point between each x-intercept and vertical asymptote. You're just getting some points off the T-chart. And of course, you're going to connect them with the smooth curves, okay? So just to kind of give you some guidance here, just to kind of summarize it. So let's do the next example. Yeah, and we'll kind of table it. So here we go. Sketching intercepts. Okay, all this stuff. Okay, here we go. So first things first, I'm looking at this function, and you know, I think I can simplify it. Can you factor the top? Yeah, difference of squares. So let's factor it. Now, right away, of course, those x plus 1s are going to cancel, so we're going to be left with this. And because those x plus 1s cancel, I'm going to add something at the bottom. You have that common factor. We've got a hole in the graph. So I'm thinking about that again. Now, I'm going to write it, of course, ordered here. We're going to find it. We're going to do all this stuff. Remember, you set your common factor to 0. And I'm just going to mentally solve it, of course. And I'll get the y coordinate once I get into it, okay? I'm just kind of tabling it there. So I'm like, let's talk about these asymptotes. Interesting. You're really over 1, okay? So I'm like, wait a minute. Let's talk about what this function is. We're down to f of x, aka y. Isn't this just plain old boring slope intercept of a line? Yeah. Okay. We can all draw a line. Let's mark out the line. Y-intercept -1, slope of 1. Don't draw the line yet because we got to do the whole. And because we know I can't draw straight, I just put a bunch of points on. I am going to connect it here in a minute. Now, here's the question for you. We are down to an expression that is not a rational function. It is not a fraction. It's simplified. So there is no vertical asymptote. There is no horizontal asymptote. We just got a plain old boring line. There is domain and range, and we'll do all of that. I need to get this hole, though, marked before I draw the actual line. Okay, well, I can do it. So if x is -1, I want the corresponding y coordinate. I'm just going to put -1 in here. -2. So before I draw it, I'm going to come down here and kind of do an open circle in -1, -2. Now I'm going to draw the rest of the line. And pretend I drew that straight, right? All right, let's answer domain and range. So real numbers. Now, normally a traditional diagonal line, the domain is just all real numbers, the range is all real numbers. It goes off for infinity, right? But we have that little gap in the old graph, okay? So we can use everything for domain except -1. You can use everything in range except for -2. And I make it really like crazy and make you write it down on this because you can get these from the graph. Just humor me. What is the x-intercept? Yep, right there at 1, 0. Easy peasy if you had to write it down. What is the y-intercept? Yep, got it right there off the graph. So intercept's pretty easy if it asks you for it. Okay. Do I want to try to do slant yet?
No.